Hi, I'm Luke Kane. Welcome to Algebra 1. Today we're going to talk about slopes and perpendicular lines. And basically the question is, given a definition of a slope, can we use that information to determine if two lines are perpendicular? Okay, now we're going to see if there's a relationship between slopes of lines and perpendicular lines. So let's start with this line segment here that has a run of A and a rise, I guess it's actually more of a fall, of B. And let's rotate this line and consequently this entire triangle. Let's rotate it all 90 degrees. Alright, so now what we've done is we've created this angle which is 90 degrees. Now to demonstrate that that's true, we move this side that's got a length of B, we move that 90 degrees. So let's just look at that again. We'll move it back. Okay, so we move this side from here to here. That's 90 degrees. And since the whole triangle is moving without changing, that means that this line, when it moves from here to here, is also going to move 90 degrees. So I think that clearly demonstrates that this angle is 90 degrees. So now that we have demonstrated that this is in fact a right triangle, all right, let us see if we can determine the relationship of the slopes of these two lines. So let's start by naming them. Let's call that line 1 as we did before, and let's call that line 2 as we did before, and let's let M1 equal the slope of line 1, and let M2 equal the slope of line 2. Okay? Now let's look at the slope of line 1. M1, well, the rise is this. It's minus B because this is going down. It's going towards negative infinity. So that's minus B. And the run is A. M2, well, if I look at that, the rise is A, and the run is B. Now let's multiply them together. Why? Why not? Well, actually, it turns out interesting thing happens if we multiply them together. So M1 times M2 is the same as minus B over A, we're just substituting from above, times A over B. Oh, that looks interesting. Let's rearrange this right-hand side. Let's take the minus out, put a parentheses in, and let's put the A over here and the B over there. Since we're dealing with multiplication, multiplication's commutative, we can do this. So we get A over A times B over B, which is the same as minus 1 times 1, which is the same as minus 1. So we now have a new theorem that says if line 1 is perpendicular to line 2, then the product of their slopes, M1 times M2, equals minus 1. Again, this is something that you should memorize or put in a cheat sheet, but have available because you will need this to do computation. Some people don't like this particular form. We can use another form, and that's easy to derive. So we take M1 times M2 equals minus 1. Well, let's divide both sides by M sub 2. That cancels because that's 1, and now I get M1 equals minus 1 over M sub 2. So I can rewrite this theorem by saying if line 1 is perpendicular to line 2, then the two slopes are negative reciprocals. Okay, that is, I flip the second slope and I multiply it times minus 1. And this is an equivalent form of that. So what did we learn? Well, we learned that if two lines are perpendicular, then the product of their slopes is negative 1. If we multiply the two slopes together, we should get negative 1. Or, as the notation we used in the example, m1 times m2 has to equal minus 1. Another way of saying exactly the same thing is to say that if two lines are perpendicular, then the slopes of each line are negative reciprocals. In other words, if I take one reciprocal and I flip it over and multiply it times minus 1, it's going to equal the other reciprocal. And that's it. It's pretty straightforward. Next time we're going to look at linear equations in the real world after we do a problem or two with perpendicular lines. I'm Luke Kane. Thanks for watching. Bye now.